Hi, welcome to Coursera's Instrumental Analysis. I'm VICKI COLVINE. What we're doing in this lecture is actually an overview of case study 3, which is all about breathalyzers. And in this case study, I'm trying to challenge you, besides learning a little bit about infrared spectroscopy, some more about gas chromatography, as well as introducing you to electrochemical sensors, I'm trying to get you to think a little bit about the common situation of having multiple conflicting needs all sort of wrapped up in a measurement problem. And it's not as if there's a single right answer to this problem. So you're going to be basically advising a community on what kind of breathalyzers to invest in order to better handle both drunk driving and underage drinking in the setting of a campus. So let me lay out the case study. So the setting is We Are Famous University. And this is not a real university, but it is your case study. And in this university, there's about 3,000 students, 9 dormitories. Most of them are residential, so they live on campus, but 20% live off campus and are very much a part of the campus culture, particularly the party culture. There are no fraternities on this campus, so much of the underage drinking culture resides in the residential colleges. It's a wet campus with many traditions surrounding alcohol consumption. And it's an independent student body with a very, very strong student governance process. For example, a lot of alcohol education is managed by senior students who live in the dormitories and are alcohol educators for the younger students. You have a lot of young people away from home for the first time, and so like many college campuses, at least in the United States, it faces a lot of challenges in balancing both the privacy of students, the individual rights of students, the desires of parents, and of course the institutional need to protect itself and its students. So the problem that's arisen at We Are Famous in the last 2 years is a rapid increase in the number of problems associated with student drinking. And the problems really aren't about underage drinking, but about medical issues that have come up when students drink too much. The most notable of which are called emergency room transports, situations in which students had so much to drink they became unresponsive and had to be transported to the emergency room. And that number has risen steadily over the last couple of years. The other and more tragic problem is, of course, drunk driving, and the fact that students recently, in the last semester in your case study, there was an actual accident involving several students who were leaving from a party on campus to return to their off-campus apartment. So, like many college campuses around the country, this particular We Are Famous institution is not immune from a lot of the challenges faced with underage drinking. So one of the things that you need to understand about the measurement problem at hand is alcohol in the human body, because the police, when confronted with this data, and there's a local campus police force of about 10 officers, really started to consider whether or not they should become more trained and more equipped to measure the blood alcohol levels of students and drivers on the campus. So in a body, as you consume alcohol, there's many, many different effects on your entire body. But when you look at the blood levels, the concentration of alcohol in the blood, that's sort of considered a really good indicator for how impaired you might be. And there's very strict state regulations across the country. The 0.08 grams of alcohol in 100 mils of blood constitutes being intoxicated. You don't measure blood alcohol by extracting somebody's blood and analyzing the ethanol in it. You actually do it by looking at the amount of alcohol that might be in somebody's breath and inferring what must have been in the blood. So going back to those partition coefficients we looked at, there's a partition between the bloodstream and the airways. And that partition is on the order, when you take all the volumes into account, of about 2,100. So if you measure a certain amount of grams of ethanol in the breath, you can convert it to what the blood alcohol level must have been in the blood. And that's a really key for almost all the measurements, save one I'm going to talk about. You're getting at the blood alcohol level of a student or driver based on how much alcohol is in their breath. Now, let's go through some of the measurement needs in this problem. So there's a couple of different stakeholders here, so that's one of your challenges. So the police really want to be equipped to measure blood alcohol levels, and they believe they should be equipped because of the recent drunk driving incident. And so they want to be able to stop drivers on campus, and if they suspect a driver is drunk, to administer basically a test that evaluates that. And they would like to have a measurement method that is what's called an evidentiary standard, meaning in a court of law, it would be considered quantitative evidence of somebody being drunk. So they want to measure blood alcohol level through somebody's breath using a measurement device that is a legal standard. The campus lawyer is very aware, though, that if you pull somebody over and you try to write a citation for drunk driving and you haven't done 2 tests, you open yourself up for lawsuits. So the campus lawyer would like to have a second evidentiary standard. At large police stations in many cities, if you have a breath reading of alcohol that's too high, you get transported to the police station where they do a second different kind of measurement. And so those two together are kind of evidence that, well, if one was a little off, it's unlikely 2 would be off. And since many people do contest DUIs, it's become really standard and required these days to consider having 2 evidentiary standards, especially in the assignment of a DUI. So the parents, of course, are horrified by this kind of activity. They're worried about their kids being at risk, and they want a much tougher standard. For example, there's a group of them that's been lobbying the administration to install on parking gates fixed breathalyzers that you have to blow into in order to exit the parking lot. And they reason that with that kind of control in place, it would be very difficult for a drunk student to leave the campus drunk. And so that's one idea of the parents. The students have some interesting ideas. They also want to deal with the problem, but they really want to go at it better through education. There are breath strips that you can use to measure your blood alcohol level in kind of a generic way. And some students have even suggested installing fixed breathalyzers in the dormitories, and other students have suggested that may not be a good idea. It could actually turn against the administration. Nevertheless, the alcohol educators have noted that some of the biggest problems with student drinking occur in the youngest students who've never had alcohol before. So they really don't know how much they're drinking and what their body's doing with it. So they think some kind of ability for the students and the student educators to measure blood alcohol levels in a safe environment could actually be very informative for some of these younger students who really, as I said, are experiencing alcohol for the first time. That's the student viewpoint. The police viewpoint is, in addition to the drivers, they also are responsible for patrolling on foot the parties that occur on campus. And they like the ability to do and administer breathalyzer tests to those students that they think might be impaired during a party. So they need a handheld device for that purpose. The constraints on these measurement devices are somewhat severe. The campus can only afford to spend about $250,000 per year on whatever set of activities they do to help their police force, their students, and the entire campus really handle the issues of underage drinking. The cost of a medical technician to draw blood, which is the end goal, as you're going to see in one of the methods, is about $200,000 a year if they were to staff their small police station around the clock, which is pretty much a requirement if you're going to actually take blood from people. And then the cost of sending out blood samples to the city police is about $1,000 a sample. Okay, so let's talk about breathalyzers. So breathalyzers, by definition, are analytical methods that measure, as I said, alcohol in breath by measuring and then inferring the blood alcohol levels. And there's a whole host of them. You can have there's an app for that now. You can get a breathalyzer that plugs into your iPod or iPad or iPhone. There's a keychain breathalyzer. There's fixed breathalyzers that are in bars so people can check before they leave if they're over the limit. There's breathalyzers that fit into somebody's car. So a lot of people with multiple DUIs actually have these installed and they're unable to turn on their car until they blow and indicate that they really don't have any alcohol in their system. And of course, the one in the lower right is the one that a lot of police in a lot of states use when they pull somebody over the side and they need to administer a breath test kind of in the field as opposed to at the station. So let's talk about some of these approaches. So the one that you do in the field is pretty much state-of-the-art system. It's usually a fuel cell, and we're going to talk about what that means, and you're going to have some reading on that. And it can be quite accurate. And remember, that's going to be an issue, the accuracy and precision, especially if you're taking a measurement that would lead to a legal action. So it really, really is a critical parameter in this particular kind of measurement. Another really interesting measurement is a colorimetric breath test. These are the strips I was talking about. So what you do is you wet a strip with a little bit of saliva, and it turns color based on how much alcohol is present in the saliva. It's kind of an interesting proposition, and you'll be provided with the cost of these strips on the website, so you can sort of figure out how they might fit into your plan for the entire campus. One system, and you'll have some reading on this too, is the Headspace GCMS. So in many police stations across the country, Headspace GCMS is becoming a really standard tool as one of the second evidentiary standards. The only trick is that it's got to work on blood. So you take a blood sample and you measure the headspace above the blood for the alcohol level, and you work backwards to the blood alcohol just based on the air-blood partition as opposed to the partition you might have in the lung. So it's not really a breathalyzer test. Anyhow, this test has the advantage of overcoming one of the biggest problems of both the fuel cell and the colorimetric analyzer, which is that if you're diabetic, or let's say you're on a really high protein diet, you actually may exude in your breath a lot more ketones, for example, than a normal person. And those may, in some of those other methodologies, look like alcohol. Because, again, this is an issue of specificity. There's nothing more specific than a GCMS because it's separating the samples by elution time, and then it's doing mass spec. So you're really measuring very, very perfectly and exactly how much ethanol is there. So it's a really interesting method to consider in your planning for the campus. The fuel cell technology I mentioned before is described here, and I'll let you basically read it. It's using alcohol as a fuel to basically drive kind of a battery in the inverse. And it's a pretty robust system. It works pretty well. The main problem is eventually the electrodes start to corrode, and when they do that, the machine can basically become uncalibrated. These are used, both the more expensive ones as evidentiary standards, and the cheaper ones are some of the basis for those sensors that you saw, for example, the ones that attach to your iPhone. So the last system I'll talk about is an infrared spectrometer called the Intoxilyzer 5000 or 8000. There's two versions. And it works by measuring the alcohol content directly through infrared spectroscopy. It doesn't scan all the wavelengths. It's not an FTIR, but it puts in two interference filters that allow for 3 microns roughly and 9 micron detection. And through that, it's able to deal with this problem of interferences in blood alcohol detection. And it's also pretty cheap and easy compared to some of the others. It's considered to be an evidentiary standard in most states, although the more recent Intoxilyzer 8000 has met some resistance in some states and challenges based on its accuracy. Here's an example of the kinds of spectra you might get comparing both a ketone against an alcohol, and why, if you particularly look at the CO stretch region, you can actually distinguish the two. So the questions to consider in the case study are going to be diverse. You're going to have to figure out the various interests and needs of all the stakeholders, and that'll be explained also more in the handout. You're going to have to figure out what kind of measurement does each of these groups want. What are they interested in doing? You're going to have to come up with a plan given the budgetary constraint I gave you, and actually propose, here's what the steps I would say We Are Famous should do with respect to an analysis solution to this problem. Of course, this problem is a very broad one. It could involve a lot of deeper analysis of what the institution might do to deal with the underlying issues. But in your role as an analytical chemist, you're going to be looking at, okay, what are the choices available and how could they be useful to helping this institution make a safer and happier place for everybody? Thanks so much. I'll see you next time.